Sorry for the first part. In the last, just there was 3 minutes remaining. My electricity cut off. Anyways, this part is going to be more interesting, I guess, and it's going to be shorter, so we have more chance to ask questions, even questions about the drilling fluid. So in this part, we will be discussing about the casing and cementing. Okay, why we need to case any hole. Of course, as you know, there's no well in the world which is drilled in one section in case one casing. It's always in section wise, section by section. So why we case any open hole is, as you see in here, the reasons are: first, we discussed a lot of issues on the formations. It can be natural issues, or it can be by poor mud or any reason like that. The hole doesn't last forever like that. It will collapse if you don't set a casing to support it. So prevent the cave or washouts of the hole. Like I said, if, for example, if you're drilling, your bed is 8.5, your hole is supposed to be 8.5 hole, but because of improper mud or because of natural fractured formation or whatsoever, the hole collapses. So that's why we need to a constant ID and constant OD, then you have a regular shape for your hole. So this is one of the reasons for setting any casing. And then the contamination between the zones. For example, if you drill 8.5 section, you have water zones and you have shell problem formations. And after that, it's time to drill the 6-inch hole. You want to isolate the 6-inch hole from the above section, which is 8.5. The 8.5 section must be isolated or must be cased. So that's why we set the casing at 8.5. You get rid of any communication between 8.5 and 6-inch hole. And the 6-inch hole is a reservoir, but the 8.5 was problematic shell formation. So you can isolate the 8.5 from the 6-inch hole. I can say once you set any casing and you cement it successfully, it becomes history. Okay, you don't deal with any issues anymore with that section. So your goal is gonna be to drill the next section only. As soon as you case and set history in the hole, any section. Um, like I said, if you have water with the oil in your reservoir or above, you have some water formations. You can exclude that water by setting casing in that section. Confine production to the wellbore. If you imagine, we usually, it depends on what class of hole you are drilling. If it's exploration, for example, you usually start with 36-inch hole or 46-inch hole. If you have that big 46-inch hole, it's more than 1 meter. It's about 1.3 meter big hole diameter. If you continue the same thing, just imagine all the way to the well TD, which is about 4,000 meters. You cannot have 1.3 meter of hole all the way to 4,000 meters. You need to shrink it one by one. So that's why you need to set the casings, and then in the end, the last casing string is going to be slim casing, so you can run your tubing, production tubing or completion tubing. It's usually 3.5 or 4.5 tubing that can be centered and that can get along with 7-inch casing rather than 40-inch casing. So that's why it gives a confined production to the well bore. Provides a mean of controlling the well pressure. As we discussed, the formations have pore pressure, a trap pressure. If you, while drilling, your mud, as we said, is the key to avoid from getting any pressure inside the hole. But after you finish the section, the open hole, you pull out your bit and all the other tools, and then you run your casing, and then after the casing, you send the cement between the casing and the formation behind the casing, and then it's done. That formation pressure cannot create any issue for you anymore. So that's what provides a means of controlling well pressure. Provide a path for produced fluids, tubing, or sometimes the casing itself. If you cannot produce through an open hole, you need to have a steel tube or casing so you can produce hydrocarbons through. Permit installation of artificial lift equipment. That's another point of having casing. Okay, casing is usually consists of these types from the top to the bottom. The first casing is called conductor. Conductor usually, for example, if you take Ishkan as example, for conductor we don't have rig. We don't have this rig. We just drill about 40 to 30, sometimes 20 meters, and then we set a 20 meter, 25 or 30 meter of this conductor pipe. It's a huge pipe and it's totally different than the rest of the casing. It doesn't have any thread to connect. They are welded together. And for cost saving, you don't have rig in here. You just use the crane because it's only 2 or 3 joints of conductor. And then after that, you have the surface casing, which in our case is 1338 casing because we are in the development phase. But in the exploration, you can have also bigger size of casing. And then you have intermediate. In our case, is 958 casing in the middle section. And then you can have a 7-inch casing or a liner. The difference between casing and liner, we call any casing liner if you don't bring it back all the way to surface. You can hang it inside the previous casing. If you see in here, this is 7-inch casing. It's hung inside the 958. But if this casing is all the way up to surface to the wellhead, that's called casing. So that's the difference between casing and liner. And then after that, the last string of tube or casing is called production tubing, or sometimes you have more sections of the casings. This one is still casing, but in our case, after the 7-inch casing, we only have the production tubing, which is 4.5-inch tubing in our section. Casing properties. Usually, when you talk about the casing, just like your car, when you say it has this feature. There are some main features of your car. So the casing has some features which can be recognized by just telling them. One of them is range indication, the length. Worldwide, the majority of the casings are between 9.5 meters or 9 meters to sometimes up to 14 meters. More than 40 meters, it can be very difficult for transportation because the normal truck can load 14 meter, even less. So that's the range. The size, when I say 7-inch casing, maybe everybody can ask that question, what do you mean by 7-inch? Is that ID of the casing or OD? When we say 7-inch casing, we always mean by the OD of the casing. Why? Because the OD stays the same, but the ID can vary. It depends on the casing wall thickness. There are some casing, the wall thickness of the casing is bigger or thicker. There are some thinner. And also, after a long period of time, when you produce, for example, in tubing, if you produce all these hydrocarbons, as we discussed about corrosion can make the wall thinner, so the ID can change. So that's why we never call a casing by its ID. We always call it by its OD because the OD is constant. Weight. Another specification of casing, when I say someone tells me that casing is 7-inch, if I want to know the ID or the wall thickness, the thickness of the casing, I can ask what's the weight of it. If I'm talking about the 7-inch casing, it has 23, it has 29, it has 32 pounds per feet. When you know the pounds per feet for the casing, then you can know the ID also. So that's the weight specification of the casing. And then connection. Of course, not all the casings have the same connection. This connection means that type and the shape of the thread. The thread, we have 2 major threads what we use in Kurusan for casings: BTC or buttress connection and VAM top. Those are main connections. BTC can be used for upper hole, which you are not interested in. There's no gas, no FPS, no problem. But VAM top is called also a premium thread. You use it most of the time for the 7-inch casing, because in the 7-inch casing there's possibility for hydrocarbons, and it's more durable connection. And then also you have the grade. You have LAT, SAT, whatsoever the grade of the casing. When someone tells you that casing is L80, that means the grade. The grade means the strength of the casing, of the material, what kind of material has been used to manufacture this casing. So that's what we mean by grade. There are dozens of grades, and it's the drilling engineer's job, before we drill the well, to specify all these features. Of course, casing a part of, like I said, between 9.5 or 9 meters to 14 meters of long pipe. It has also some accessories. The accessories, the main one is centralizer. Centralizer, from its name, you can know that it's used to centralize. This is your open hole, it's 8.5. And your casing is 7-inch. Like I said, the 7-inch means the OD. So how can you center this 7-inch casing inside this 8.5 hole with a almost equal distance from each side, so it can center by using these centralizers? So these are called centralizers. There are some other types. These are scratches. We never use them. This one is to eliminate from the filter cake. In case if you have a thick filter cake, if you use them, it can remove the filter cake while running the casing. And here we have a shoe. At the bottom of each casing string there must be a guide. That means a taper shape, so it can penetrate and it can go down. It can gives you a good path. So this is the guide shoe, and this one is the float shoe. Float shoe, as you see from here, like I said, it's from the bottom of the casing, and then you have a joint of the casing, and then float collar, and then the rest is just normal casing joints. The float shoe has a function which is done by this valve. It's either flapper valve or spring valve or whatsoever. This is a one-way valve. It exists in all types of the float shoes. This valve, like I said, it's a one-way valve. So that means you can pump mud or cement, everything from inside. It goes from here, and then it goes to the annulus. But from the annulus, if for some reason the cement or any fluid try to come back to go inside the casing, this valve holds it. It doesn't let any fluid come back in here. This is called, if that happens, if this valve fails, if your cement comes back opposite way from annulus back to inside casing, that's called a U-tubing effect. Okay, that's a failure, and if that happens during cementing, it's a big issue. You have also the float shoe, like this one. It has different types of shape at the bottom. The nose has different types, and also the valve is a different mechanism. It's either flapper or spring or whatever. And then we have the float collars. Usually, like I said, from very bottom you have the float shoe, and then 1 or 2 or sometimes 3 joints of normal casing, and then you have a float collar. The float collar has 2 functions. First of all, it's gonna hold the wiper plugs. After you drop them, they stay here on the float collars. And plus, it also have the same valve as the float shoe. If this float shoe we discussed, if this valve on the float shoe fails, and then your cement tries to come back in here, but you have a float collar, like I said, 2 or 3 or 1 joint above this float shoe, then the float collar is doing his job. It's going to be a backup for the float shoe. So the float collars has 2 functions, like I said. First, to hold the wiper plugs. I'm going to show you an animation about the wiper plugs, and also gives a backup meaning for the float shoe. The float shoe fails the valve, the float collar can be the second option. Okay. Usually, the rig crew and the rig equipment are running any tools inside the hole and pulling it out because that's a routine operation. It's a common operation. You cannot hire uh, a special company just for doing that. If you do so, then your budget of the well is going to be double or triple. But for casing, you cannot do that. The rig people are not familiar with running casing 100%. And it is a critical operation. It's not like the pipe. The pipe can be fished if something happens, and then the pipe is run and pulled all the time, and it doesn't stay in the hole forever. But casing is a permanent achieving. So that's why it needs optimum care while running hot. Any problem while this connection, if it is in the reservoir, this you said this casing in the reservoir. If you make this connection, two joints together, if you make them in a wrong way, then you are done. It takes weeks to to do the remedial action for this. So that's why it needs more care than normal running pipe and pulling out. So this also the connection between two casing joints is done by what they call power tongs. It's not for normal drill pipe. You use the rig tongs. I'm going to show you the rig tongs. And nowadays there's also what they call iron roughneck. It's just making connection by rig equipment. But for casing, no. You have a power tongue, and also it gives you the power tongue gives you the torque. You know for each casing how much torque you need to apply. Like I said, torque is the rotational force. And also the slips for casing is different because obviously the casing is slick. It doesn't have any tool joint. So from the bottom all the way is 7 inches, but the drill pipe, not. The drill pipe has tool joints. That means on the top is like wider, and then normal body, and then at the bottom you have pin connection. So these are power tongues. It can be used in rare cases. Most of the time, just if you use for the first and the second joint of the casing. Otherwise, you always need the power tongues, which is done by a special company. They come for the rig side only for running casing. Only there are many companies that are doing only running casing. That's their job. And then if you take a look at this elevator, it's different than the drill pipe elevator. The slips, if you see this slip is different than this slip. It's different than this slip. So the slip, the elevator, and everything else can be changed for casing. Okay, that was about the casing and its accessories. Now, if we talk about the cementing, it has this accessory which is called the cement head. If you take a look at here, this is your rotary table. You run all the casing down. If you are lucky, you set it on the desired depth. And now this is the last part of the casing, which is usually 1 to 2 meters above the rig floor, which is called stick-up length. And then on top of this, you install an equipment. It's called a cement head. Okay, so this is the cement head. You install, like I said, on the stick-up length, and then before that you load 2 plugs in this cement head. I will show you the plugs. Okay, so you can drop each plug at a time for the cementing operations. These are the wiper plugs. I will discuss about these wiper plugs. Basically, they are just to wipe the casing, to wipe from any cement, and also to separate the cement from the normal. These are the real pictures of the plugs. From its color, you can know one is the upper plug and the other one is the bottom plug. These are about the cementing. And of course, as a drilling engineer or even well site drilling engineer, even the drilling supervisor's job is to calculate how much cement you want. Any volume or capacity has been simplified in the field. All you need to know, for example, if you want to know how much, of course, in the plan, you need to know how much cement you need, how many meters in the annulus. For example, you need 200 meters. You know that now you need 200 meters. The first thing you calculate is how many barrels you need for 1 meter, and then you multiply by 200 meters. You say I need this much of cement. How you calculate for each 1 meter? If it's an annulus, that means between two things, two sizes. You take the diameter, the ID from the outer or the bigger, minus the OD of the inner, times 1029.4. This is a conversion factor used in the field. And then it can give you a barrel per feet, and then you times 3.281. It gives you barrel per meter. So that's very, very basic. For example, if this is 8.5 hole and this is 7-inch casing, you say 8.5 square minus 7-inch square divided by this number times 3.28. It gives you barrel per meter. Your company tells you they need 200 meter of cement in the annulus, so you just simply multiply by 200 meters. You know how many barrels you need in here. And sometimes, if you think your hole is 8.5 bigger for the reasons I mentioned, then you need more casing, which is called excess. You say after you calculate for this, you add also like 10%, 20%, 30% to what you have calculated, just to be on the safe side, because your hole is not 8.5, probably is bigger. Okay, so that's the calculation for any cement calculation. Or if you want to calculate inside the casing, this equation applies because it's only inside. So inside, that means the ID of this casing, if the casing is 7 inches, the ID is 6.184 usually for 32 pounds. You say 6.184 square divided by this times 3.281, that's in meter, barrel per meter, and then you times how many cement you need in the casing. That's a very basic thing for cement calculation. Like I said, that's drilling engineers, drilling supervisor, well site drilling engineers calculation. Everybody calculates just to cross-check if your calculation are matching. Okay, now there is an animation. I will show you that animation, and then we can discuss any question if there's. Okay, just give me about probably 2 minutes for that calculation, and then we will have about 15 minutes for discussion, I guess. Okay, and here, okay, first of all, this is what we discussed. This is your casing. This is casing all the way to the bottom, or 2 meter, what they call rat hole. You usually set your casing by 2 meters or bottom, or 3 meters or bottom. It doesn't matter. So in here, your casing is all the way to your rig floor. Okay, on the rig floor, this is the cement head. I showed you the picture of the cement head, and then your cement head is lined up, is connected to the cementing unit. Okay, so now before you do any cement job, you just make some circulation, or what I mean is just pump some mud, sometimes one volume of the casing or 1.5 volume of this casing. Sometimes you just roughly circulate for 1 hour just to clean the hole for casing, condition the mud, and then it's time to pressure test your cement unit. And here there are a lot of valves, a lot of connections. This is, in a typical case, is about 40 meters of pipe connection and all these valves. There's possibility for leak. So you close this valve or any valve somewhere else, so you can apply pressure from this cement unit using just water. Just inject water to your pipe until you see a pressure and wait for certain minutes of time. Then you pressure test, you make sure your lines are holding pressure before you have any failure downhole. And after that, like I said, that's the mud circulation, as you see. This dark one goes back to the shell shaker, to the system. And then after that, you pressure test. If you take a look at here, this is the gauge of the pressure. You apply pressure on these lines all the way, and then you make sure they are holding pressure. There's no problem. And then you pump the other mud material just to condition the hole. And then you pump the spacer. Spacer is any material you pump before you pump the slurry, the cement. The spacer, from its name, it gives you space between your mud, which is currently in the hole, and then after that the cement is coming, the cement slurry. So this is separating the mud from the cement. That's the philosophy of spacer. And then after that, you open one of these valves. The plug I showed you, you drop the bottom plug. Okay, now your bottom plug is dropped. And then you pump this is your bottom plug. It goes down, and this is spacer ahead. And then now you pump your slurry. You pump the cement. Cement usually consists of two types of weight of cement. One is called lead and one is tail. The lead is lighter cement, like you see in here, and then the tail. So now your plug, the wiper plug, is on the float collar, like I mentioned. It stays in here, and then you have the cement, the calculated volume you pump by the cementing unit. It stays on this plug. Now it's time to rupture this. Usually this bottom plug is ruptured by 500 or 600 psi, so the cement can pass all the way from here to the annulus. Okay, so now you drop the top plug. The cement is confined between two plugs, so it's separated from the mud below and mud above. This is the slurry, this is the lead, and this is the tail, your cement slurry, bottom plug, top plug. And now you need to displace. You pump, this is mud. You pump, push down. The bottom, the top plug, you push it down all the way to the bottom. The bottom one is already ruptured. Your cement is gone to your annulus, and this is where you want to be, right? So both top plugs are on top of each. Both plugs are on top of each other, and now you have mud inside your casing, and you have cement only below the float collar inside, only below the float collar, and then the rest of the cement is in the annulus. Now you set your casing and you isolated everything. And then after that, you just after you pump the displacement, this mud, you see some pressure. As soon as you see the pressure, that means this plug has been reached on the lower plug, and now your cement job is successful. And then you shut off the pump. You don't pump any more mud, and then you wait for a few minutes to see if this valve is holding. There is no back flow to your cementing unit. If there is nothing coming back to your cementing unit, that means this cement is in the annulus, and there is no way, and this valve is working fine. It's not coming back to your cementing unit. So that was the discussion about the cementing and casing. Even though the time is very short and online is not very good way for explanation, but now we can take the questions. As I see in here, we have about 9 minutes.
Yeah, exactly. Thank you, Kakhemen, for this impressive seminar. Dijans, if you have any question, you can ask him. Either about cementing drilling fluid.
I have one question, Mohammed.
Yeah, Kakhemen, go ahead.
Thanks a lot, Mr. Heyman. My question is about casing connection. As I know, we have 3 types of casing connection.
Just specify.
3 types, yes. The short casing connection and long, and another one, I don't remember the name. So my question is that when we use each one of them, and which one of them is better?
Okay. The connection is, I've not heard of the length difference in the connection. The connection difference is in the type, in the shape of the thread. Okay. The type of the shape of the thread, there are more than 3, but in Kurdistan we usually use 2 of them, which is buttress and VAM top. The buttress, we use it for the top hole. That means the first section, because the first section we don't have oil and gas in there, so we are not so worried about the AH2S and corrosion and things like that. But for 7-inch, or if you have a slimmer casing, we usually use the VAM top connection. The VAM top is a double seal. Like I said, online I cannot show you, but if you take a look, just visually, if you take a look at the thread, you can know this is VAM top and this is thread. VAM top has 2 seals. So it's giving more meaning for sealing, for hydrocarbons, for H2S, for gas, for corrosion. So briefly, we use VAM top connection for lower sections and buttress connection for upper sections where we don't have any oil and gas.
Thank you, Kakiman. Any other question?
Yes, please.
Yeah, go ahead, Kakiman from
Kakiman.
Tsinghua University.
Yes, and thanks so much for your presenting. Actually, I have two questions. The first one is...
Bro, I think we don't have enough time. Only one question, because
okay.
Yeah.
Okay. You say for the conductor, is for the first time that you'll casing. Should we do the cementing also for the conductor? I mean, maybe 20 or 30 meters at the first.
Yes, we usually cement the conductor pipe also, just like the other casings. But the cement head is we do it just by the mixer you see for construction. The people are using it. We just pour or dump some cement from the surface to the annulus behind the conductor pipe. That gives you your casing, your conductor will stay in its place and it doesn't move at all. So that's but it's not that critical as the other cement job. The lab data is not that accurate because, like I said, it's just done by the mixer, construction mixer, or you can just dump some cement by any meaning of equipment. You don't have any lab data. You just make a slurry of house building, same slurry. You just dump it, but you have to do it so the conductor can stay in its place.
Okay, thank you, Kakiman. Thank you, Kagbro. Any other question? Because I think Engineer Sadaq, I think it's the third time that you say have a question. Yeah, you can go ahead.
Hello, Mr. Heyman.
Hello.
Go ahead.
So we can drill a well in just using one type of casing, or should be a set of casing?
Okay. Now, there is no way to drill any well with one casing size in one casing section. Any well is in a tapered shape. You have a bigger hole and a bigger casing, and then a smaller hole and smaller casing, smaller hole and smaller casing. There is no well in the world with one casing. I've never heard of that.
Okay. Thank you, Kak Heyman. Mohammed Akram has a question. Go ahead, Kak Mohammed.
Thank you, Kak Heyman, for explaining, and I have just a question for you. Kak Heyman, after we complete our process of the casing and cementing, this meaning this process will remain with the well to the end life of the well. Take it a problem will happen, like a breaking for this process or a manufacture happen for it. So what's the solution for this situation? And are you faced like this problem before now or you're hearing about it?
Yeah. Okay. Yeah. Usually, the problem with a casing, if it depends on many factors. If you have a problem, for example, if you see that your connection has a leak, or you've already made a connection between two joints of casing, but you are not happy about them, or you see a sign of leak or something like this. It depends. If you are close to bottom, probably the company just tells you go ahead and set your casing and cement it. If you have run only, for example, 10 joints, it's easy to pull out that 10 joints and find the problem, troubleshoot the problem, and then rerun. But usually the problem on casing, running casing and cementing, any failure can be very costly and very time-consuming process. There are many remedial actions if your casings fail, the connection or the leak, there's a hole in the casing, anything like that, or if you cannot cement your casing, there are a lot of remedial actions, but I don't think I can explain those remedial actions on this online course. I'm sorry, but if you have a private time for the university, or if there's any chance after this lockdown curfew in Kurdistan, then we can discuss this in more detail.
We will arrange it. Yeah. Any other question, guys?
I have some questions if possible.
Yeah, Mr. Abdulsalam, go ahead.
بعد كردي سيارة كما كم زور سپاس که من بو شرحی جنابت بوی کو همو بجدارکان خاص بین لبوی حدا کم به کردی بسیار کم که من زور سپاس بو شرحکانی که زور جوان لسر اقصاد کرد یک بسیار مویه که ام فورمیشنانه که رزروایرن ل HKN ل فیلدکه دیپسکیان چنده دوم بسیار مویه ایوه بندینگ تایم تان لکاتی کلنا فورمیشنی رزروایر فورمیشنن بندینگ تایم تان چند ساعته دویج لچه تایپک لسیمنتکه بکارینم.
اوكي زور سپاس برز عبدالسلام بالنسبة أوي رزرفوار طبعا ما دو رزرفوار من هلا إيش كي يكشان تراسيكا يعني لايد أولي كده يكشان جوراسيكا لبرو زور كوستيا انترستنين لي وإنتاجي ناكين بس تراسيك عادة اما بس سكشن 16 شغل يعني كيسين 7 يجمع داقر باش لو 16 شغل هم رزرفواري اما تقريبا ل 2900 متر تي في دي لبين 2900 حتى 3000 متر تي في دي شو فرقي هي او يعني لقل تي في دي سمنتش كلاس جي سمنت بكارديني همو سمنت
كلاس جي
كلاس جي والله مثلا سكندك من مايا بس كلاس جي بكارديني سباز بسعر كان
بندی تایم تان چند که من ببوره چند ساعته با کادی کلنا فرمی رزروایر فورمیشن
حسب لاب دیتا بس اگر پیش 12 ساعت بله
ممنونم.
Thank you very much. I'll end up the meeting. Thank you, Kakeman. You're welcome.